Question 10. 40 slips of paper are numbered 1 to 40 and placed in a hat. So within the hat, there's numbers from 1 to 40. Alice and Bob draws one number without replacement, and Alice says this number, or this statement. She says, I cannot tell who has the larger number. So when you want to consider possible scenarios, given a range of numbers, and you have a statement like that, is typically a good way to just begin by looking at the extremes. So the extremes are 1 and 40, right? Let's assume that Alice has 1. If Alice has 1, could she determine who has the larger number? The answer is yes. Why is that? 1 is smaller than 2, 3, all the way to 40. 1 is the smallest number within the series, therefore, if she has the smallest number in the series, then Bob would automatically have the larger of the two. So Alice's range of possible numbers could not have included 1, so it only could have started at 2, 3, and onwards. Now let's look at the second extreme, which is 40. If she drew 40, could she know who has the largest number? She can, because 40 is the largest number, so any other number is smaller than 40. Therefore, she could not have drawn 40 if she were to not know who had the larger number. So this would be 39 as its upper range. Now let's consider Bob. Bob says that I know who has the larger number. So if Bob knows who has the larger number, that means he could have either had 1 and all the way to 40. And why is that? Because if she had 1, similarly, if he had the smallest number, then that means he knows Alice had a larger number. If Bob had the largest number, then he would know that he had the largest number, and therefore the largest term of them too. But at the same time, remember, Alice could have drawn anything, in between, which is like, I don't know, 22. And there's a chance that Bob drew, I don't know, like 39. And we cannot eliminate that scenario, so therefore we have to consider the range of 1 to 40. Now, moving on, we know that in that case, if I multiply your number by 100, which is 100 times Bob's number, and add my number to it, which is Alice, the result is a perfect square. So B has to be a prime, and it has to be a 3-digit perfect square. So to do that, how would you be able to do it? So B cannot equal 1 because 1 is not prime, so B could start at 2. If B is equal to 2, then that becomes 200 plus A. So what can A be? Well, we know 15 squared from the trick, 225. So A could equal 25, and that's within the 2 to 39 range, so there's a chance that A is equal to 25 and B is equal to 2. But there's no other 3-digit perfect squares with the first 100 digit to be 2, because 16 squared, as we know, is 96, so 256. But 56 right here is larger than the upper bound of 39. So that's the only 3-digit perfect square with 2 as a 100th digit. Now let's try B is equal to 3. If B is 3, that's 300 plus A. So if 300 plus A, well, what perfect square has a 100th digit of 3? Well, we know that 18 squared, right? If you multiply it out, 144 and 18, that would be 324. So in this case, A could have drawn 24, and B could have drawn 3, right? Because that still works. And we also know we can try other numbers as well, right? So 17 squared. So let's do 17 squared. 17, 1117, so 289. So that goes back that 89 is larger, so this won't work. So 18 squared would work, 18 squared would work, but 19 squared, well, that's equal to 1719, so 361. 61 is larger, so that won't work. But notice something, right? What is 25 plus 2? That's 27. What's 24 plus 3? That's 27. Both cases work, and both cases result in the same solution. So therefore, the suspicion leads to the answer, which is 27.